Algebra 2, Chapter 4.5 to 4.6 review. Here's the questions. Evaluate the determinant of each matrix and find the inverse if possible. Well, the determinant of this matrix is, we're just going to cross multiply 6 times 4 minus 1 times 0. So the determinant is going to be 24 minus 0, which is 24. Okay? So the inverse, or A prime, is 1 over the determinant, D negative B negative C A. So now we just plug in and figure it out. So 1 over the determinant is 1 over 24. My D value from the original matrix is 4. We're just flipping the D and A. Negative 1, 0, and 6. So the inverse is going to be, multiply the scalar 104 over 24, negative 1 over 24, 0 over 24, and 6 over 24. So that's going to reduce and simplify to 1/6, negative 1/24, 0, and 1/4. So there we go. That is the inverse. All right. Number 37, first step, find the determinant. Okay, the determinant of this one is going to be 5 times negative 4 minus negative 2 times 10. So I'm going to get negative 20 minus negative 20. So that equals 0. So when the inverse, or sorry, when the determinant equals 0, there's no inverse. Okay. 38. Find the determinant first. So the determinant of this one is going to be 10 times 5 minus 1 times 8. So the determinant is going to equal 50 minus 8. So the determinant is 42. Okay? If you remember, the inverse is just 1 over the determinant, which is 42. All right, make our box. D value, which would be 5, negative A, or sorry, negative B, negative C, and then an A value. So A prime is just going to be 5 over 42, negative 1 over 42, negative 8 over 42, and 10 over 42. Okay, and then we can simplify that. 5 over 42 is as simplified as we can get. Negative 1 over 42 simplified. All right, 8 would go into 42 how many times? 6. So that'd be negative 1 over 6. All right, 10 and 42 both have a common factor of 2, so we could reduce that to 5 over 21. So there we go. So there's our inverse. All right. Use an inverse matrix to solve each equation. Well, if we remember, this looks like matrix A times matrix X equals matrix B. So we know X is going to equal A prime, or inverse of A, times B. So we've got to find the determinant of A first. So that's going to be 3 times 2 minus 5 times 6. So that's going to be 6 minus 30. So the determinant's going to be negative 24. So now we got to find A prime. A prime equals 1 over the determinant. Flip your D and A and make your B and C negative. So my A prime, my inverse, is going to equal negative 1/12. I'm going ahead and multiply each term by 1 over 24. Positive 1/4, positive 5 over 24, and negative 1/8. Okay, so x equals a prime times b. So let's do our work right here. X equals negative 1/12, 1/4. Let's make our matrix a little bit bigger. 5/24 and negative 1/8. Multiplying by negative 2, 6, 4, 12. So it's going to be a 2 by 2 matrix. So let's check it out. So first row by first column. So what do we get? Here we go. Negative 1/12 times negative 2. That'd be positive 2/6. That'd be 1/6. 5/24 times 4. That would be 20/26, which would reduce to 5/6. All right, now go first column. Or sorry, first row, second column. Negative 12 times 6 would be negative 6/12, which reduces to negative 1/2. 5/24 times 12. We could simplify that to plus 5/2. Now go second row, first column. 1/4 times negative 2 is negative 1/2. Negative 1/8 times 4 is negative 1/2. Okay, go second row, last column. 1/4 times 6. 1/4 times 6 would be 6/4, which would reduce to 3/2. Negative 1/8 times 12 would be 12/-8, which would reduce to negative 3/2. So now we can simplify this matrix a little bit. We're going to get some nice numbers. 1/6 plus 5/6 is 1. Negative 1/2 plus 5/2 is 4/2, which is 2. Negative 1/2 minus negative 1/2 is negative 1. 3/2 minus 3/2 is 0. So there we have our new matrix. Okay? So we got to solve the next one. Let's look at it. So we're going to have to set this one up. We're going to have to do coefficient matrix and variable matrix, all that good stuff. So what's the coefficient of the first one? 1, negative 1. Okay. We have an x and y as our variable matrix. And our constant matrix is 3. We'll go to the second one. I've got 2, negative 1. My xy, my constant is negative 1. So now I have it looking like ax equals b. So again, we know x equals inverse of a times b. So we got to find the inverse of a. So first thing is, let's find the determinant of a. It's going to be 1 times negative 1 minus 2 times negative 1. So it's going to be negative 1 minus negative 2. So the determinant is 1. All right. If you remember, to find the inverse, it looks like this. The inverse is 1 over the determinant, which is 1. And then we're just going to go flip your D and A. So that becomes negative 1 and 1. Make your B and C negative. So that was negative 1 to start with. That'd be just regular 1. 2 should be negative 2. So my inverse is negative 1, 1, negative 2, 1. So x is going to equal my inverse of a, which is negative 1, 1, negative 2, 1, times my b. We're totally think of it that way, which would be 3, negative 1. So I have a 2 by 2 matrix times a 2 by 1 matrix. So we're going to like this one. It's going to be a 2 by 1. So my new matrix xy is going to be first row by the only column, negative 3 plus negative 1. Okay, second row, first column. Negative 2 times 3 is negative 6. 1 times negative 1 is negative 1. So my xy is going to be negative 4, negative 7. Okay. Number 42, it's already set up for us. Okay, so I got A unknown equals B. So it's going to be x equals the inverse of a times b. So let's find the determinant of a. That's going to be 4 times 1, cross multiply minus 1 times 2. So the determinant of a is going to equal 4 minus 2, which is 2. So the inverse of a is 1 over the determinant. Flip your d in a, negative b, negative c. So my inverse of a is going to be 1/2, negative 1/2, negative 1, and 2. So x equals inverse of a, 1/2, negative 1/2, negative 1, 2, times matrix B, or my constant matrix, which is 10 and 6. So we can say xy equals 1/2 times 10 is 5. Negative 1/2 plus 6, or times 6, is negative 3. Okay, so we're done with that. Second row, first column, negative 1 times 10 is negative 10, and 2 times 6 is 12. So when I solve it, my xy matrix is going to be 5 minus 3 is 2, negative 10 plus 12 is 2. All right. Last one of these, I believe. Nope, couple more. So we've got to find the determinant of matrix A, which is going to be negative 6 minus 0. So the inverse of A is 1 over the determinant, so 1 over negative 6. Flip your d in A, change your signs. Okay, so my inverse of A is negative 1/6, 0, 7 over 6, and 1. So my x is going to be my inverse of A, negative 1/6, 0, 7/6, 1, multiplied to this matrix B, negative 12, negative 6, 17, and 9. This does not look like it's going to be very pretty. Okay, I'm going to do this in a different color just so we can kind of see it. First row times first column, negative 1/6 times negative 12. It's just going to be 2 plus 0. All right, first row, second column, negative 1/6 times negative 6. That's 1 plus 0. All right. Second row times first column, 7/6 times negative 12 would be negative 14. And 1 times 17 would be 17. Okay, next one. Second row, second column. 7/6 times negative 6 would just be negative 7. And 1 times 9 would be 9. So my new matrix, sum each of those elements. 2 plus 0 is 2, 1 plus 0 is 1. Negative 14 plus 17 is 3, negative 7 plus 9 is 2. So there is our new matrix. Okay. Again, easy stuff, just got to do the steps. Next one. Again, we've got to set up a coefficient matrix first. So let's look at the first equation. The coefficient of x is 1, the coefficient of y is 2, the constant's 15. Second equation, the coefficient of x is 2, the coefficient of y is 4, the constant is 13. So I have my coefficient matrix, I need my variable matrix, the order was x, y, and then I need my constant matrix. So now I have ax equals b. So I know x equals the inverse of a times b. So let's find the inverse of a. Step 1, find the determinant of a. That's going to be 4 minus 4 equals 0. Well, if the determinant equals a, there's no inverse, so there's no solution. Okay. Going on to the next one. Question 46, physical fitness. A club of 17 students is going on a canoe trip. The group of people on the trip includes 5 chaperones. one for each canoe. Some canoes hold 5 people, while some canoes hold 4. How many of each kind of canoe should the group rent? Okay, well, we know there's 2 types of canoes. X equals the 5-person canoe. We'll make Y equal the 4-person canoe. We know there's 5 chaperones and each one's on their own canoe, so we know there's going to be 5 canoes. So we know X plus Y equals 5. All right. We also know we've got a total of 22 people, 17 students and 5 chaperones. Okay. So we know the bigger canoes hold 5 people and the smaller canoes hold 4 people, and we need them to hold a total of 22 people. So now I have a system of equations. Now I can set up my coefficient matrix. That would be 1, 1, 5, 4. My variable matrix just be X and Y, and then my constant matrix, which would be 5 and 22. Since that is set up, and again, if we remember, we talked about this being AX equals B. And if we know that holds true, we know X equals the inverse of A times B. So now let's go find the inverse of A. So the first step for us is to find the determinant of A, which it's going to be 1 times 4, so 4 minus 1 times 5, so that'd be 5. So the determinant's negative 1. Well, the inverse is 1 over the determinant. We flip our DNA, so the 4 was our D, so that goes there. The 1 was our A, so that goes there. And then we make the 1 negative and the 5 negative. All right, since it's multiplied by negative 1, we just got to flip all the signs inside. So the 4 is going to become negative, the 1 is going to go back to positive, the 5 is going to go back to positive, and the 1 is negative. So there is my inverse of A. And there is my B. So now I can set up my equation. X, well, my matrix X is what? It's really just XY equals my A prime, negative 4, 1, 5, negative 1. Times, 5 and 22. So we can set this up. We have a product. The 2 by 2 matrix times a 2 by 1 matrix is going to give us a 2 by 1 matrix. So here we go. First row by first column. So it's negative 4 times 5, be negative 20, plus 1 times 22. So that's going to give us a value of 2. Second row, first column, 5 times 5 is 25, plus negative 1 times 22 is negative 22. It's going to be 3. So we have solved our matrix equation, xy equals 2, 3. So our x value is 2, and our y value is 3. Okay. Last question, Kramer's rule. For solving a system of equations using determinants to solve for each variable, D is the determinant of the coefficient matrix. D sub y is the determinant formed by replacing the coefficients of the y with the constant terms. You can also use row operations. Solve each system using Kramer's rule. Check your answers. Okay, step 1, let's set up our matrix. All right, my coefficient matrix is just going to be 2, negative 1, 1, 3. Okay. My constant my variable matrix xy, and my constant matrix is 15, negative 17. So my D is nothing more than my determinant of my coefficient matrix. So that's just going to be 2 times 3, which would be 6, minus negative 1. So my D sub value is 7. Okay, so I'll read that right here. D equals 7. All right, my d of x is going to be the determinant of, we're going to use the constant matrix and we'll replace that with our x value. So it's going to be 15, negative 17, negative 1, 3. So we got to find the determinant of that. Well, that's 3 times 15 is 45 minus negative 17 times negative 1. So it's going to be minus 17. So my d sub x is 28. Okay, so now let's find my d sub y. Going to go use the x values from the coefficient matrix, and then we're going to replace the y values with the constant matrix. Again, we're going to find the determinant, so we're going to cross multiply. So 2 times negative 17 is negative 34, minus 1 times 15 is 15. So I'm going to have negative 49. So d sub y is negative 49. Okay? So all we have to do now x equals d sub x over d. So that's going to be 28 over 7, which is going to be 4. My y value is d sub y over d, which is negative 49 over 7. So it's going to be negative 7. So x equals 4 and y equals negative 7. Okay. Last one. First thing, let's set up our coefficient matrix. 3, 1, negative 2, 1, 5, 1, 1, 0. Okay, let's look at this. So this is really r plus 3t equals 0. So my t coefficient is 3. Remember I told you a long time ago that has to be set up right. Okay, so that's my coefficient matrix. My variable matrix is just RST. And last but not least, my constant matrix is 22, 4, and 0. So we've got to find 3 sets of determinants to get this thing done. So we're going to use different colors. So to find the determinant of D, we need the coefficient matrix. Which is 3, 1, 1, 1, 5, 0, negative 2, 1, 3. Okay, remember how to find the determinants of a 3 by 3? We're going to rewrite the first 2 columns. Now we're going to do some highlighting. So the first part of this is going to be 3 times 5 times 3, which should be 45, plus 1 times 1 times 1 is 1, plus 0, minus negative 10, plus second row, 0 times 1 times 3 is 0, so plus 0. Third row, 3 times 1 times 1, plus 3. So let's do this together. 45 plus 1 is 46, minus negative 10 plus 3 be negative 7, so minus negative 7. So my D value is going to be 53. Okay. Next one. Probably should have went a different direction, but it is what it is. Let's find D of R. So we're going to replace the R matrix with 22, 4, and 0. We're going to write 1, 5, 0, negative 2, 1, 3. First step, we're going to rewrite the first two rows, or first two columns, which should be 2240, 150. Okay, we're going to highlight my diagonals. I'm going to go ahead and do all that right now. We're going to sum those up. 22 times 5 times 3. It's going to be 330. It's 110 times 3, yep. And the other two are 0, so we're done there. Minus, I'm going to go ahead and highlight my 3. That's 0, that's 0. So minus, it looks like 12. So D sub r is 330 minus 12. So D sub r is going to be 318. Okay. So I found D sub r. I found D. I need to find D sub s and D sub t. Okay. For sake of space, I'm going to go up a little bit. Okay. D sub r, sorry, we already did D sub r, D sub s. So we're going to start with our coefficient matrix, 3, 1, 1. Now we're going to replace the s values with 22, 4, and 0. Then we're going to go negative 2, 1, and 3. First step, rewrite the first two columns, 3, 1, 1, 22, 4, and 0. Okay, to save time, I'm going to go ahead and highlight all three diagonals first. Okay, we're going to sum those up. So D sub s is going to equal the sum of these. So 3 times 4 times 3 is 36. Plus 22 times 1 times 1 is 22. And the other one's 0. So now we're going to subtract the sum of these products. So minus 1 times 4 times negative 2, which would be negative 8. That one, next diagonal has a 0. The next one has 3 plus 22, so that'd be 66. So it's going to be 58 minus 58. So the D sub s is equal to 0. Okay. Last one. So I'm going to highlight these in blue. So I have the D, D sub r, D sub s. Now all I've got to do is find the D sub t. D sub t equals 3, 1, 1 is the first column, 1, 5, 0 is the second column. Now we're going to replace the third column with 22, 4, and 0. Okay. So step 1, write the first two columns again, 3, 1, 1, 1, 5, 0. For the sake of time, I'm going to go ahead and highlight the first three diagonals. So D sub t is going to be 3 times 5 times 0, which is 0. 1 times 4 times 1, which is 4. Plus 22 times 1 times 0, which is 0. So it's going to be just 4. Minus the product of the sums of the diagonals going the other way. Okay, so I got 1 times 5 times 22, so that's going to be 110. And the other two have 0, so it's going to be 4 minus 110. So D sub t is going to be negative 106. Okay, so quickly, we're going to try to solve this. So we have everything we need. So r is nothing more than D sub r over D, which is 318 over 53, which happens to be 6. Our s is nothing more than D sub s over D, which is 0 over 53, which is 0. And our t value is d sub t over d, which would be negative 106 over 53, which is negative 2. So r equals 6, s equals 0, and t equals negative 2.